This is IS130, Programming 1. Welcome to the course. This presentation will give you a brief welcome and introduction to the course and go over the syllabus with you. I'll also discuss the software and hardware requirements for your programming IDE and in general what the policies and expectations are, and I'll also discuss Noodle, which is Norwich University's course management system. This slide provides you with a brief introduction to your instructor. Feel free to look over it. You'll notice at the bottom the three pictures. On the left is my wife Rose, and then next to her is Dante, our little tabby. He's about 9 years old. And then there's Spazzy, who's about 7 years old. Just to make sure we're all in the right place, you should be in IS130, either A or B. Those are the section numbers. And it's Programming 1. And we usually meet in Dewey 306 on the third floor, Dewey Hall, which is happens to be right next to my office. My office is Dewey 304 in case you ever need to stop by. Also, the schedule will be posted on my door. This slide is all about discussing expectations and setting the background of what this course is all about. Also, my intention here is to give you some context for which this course is given to you. So Programming 1 is typically the first course that you will take in a computer science or computer security curriculum because it develops your algorithmic thinking skills right away. Not only are we trying to give you a specific skill in C++ programming, we're also trying to teach you how computer scientists think and solve problems. And computer scientists think algorithmically, that is, we think about solving problems in a very structured way. And in the course we'll be talking quite a bit about that. So we'll expect you to develop some problem-solving skills by writing computer programs. And in addition to that, we'd like you to develop an appreciation for and follow the software development life cycle. And we'll also teach you essentially what that is, because typically that's how computing professionals will approach a problem, through this development life cycle approach. You'll use different techniques such as top-down design, divide and conquer, and flowcharting to help you develop your computer programs and think in a very structured, step-by-step kind of way. So the other reason why students take programming in computer science and security programs is because every IT professional knows at least something about computer programming, whether they use it on the job or not. Because there often comes a time when an IT professional will need to look at computer code and at least figure out what it's doing, even if he or she isn't familiar with that particular programming language. In this class, we focused exclusively on C++, and the rest of the curriculum at Norwich also focuses on C++, at least the programming classes do. So once you take Programming 1, you'll be prepared to move on to Programming 2, which focuses on object-oriented programming, and then a course called Data Structures, which is one of the more advanced programming classes that we have. One of the things that I decided to do this semester was not distribute a hard copy of the syllabus. And here's why. Number one, we can save a tree, because there's an awful lot of paper that's involved in being educated. You can download an electronic copy of the syllabus right from the Noodle course site, and I recommend that you do so immediately so you become familiar with what the expectations are, what the grading criteria is, and so forth. The syllabus is a guide and a contract, specifically the policies, procedures, and course objectives and the assessment criteria are all part of this contract, and they are non-negotiable. You want to pay attention to the course objectives, because what I try and do is tie every single assignment in the class to those course objectives and help you meet those course objectives by the time you're done the course. Also, when it comes to grading, I don't grade on a curve, nor do I scale quizzes, tests, or any other type of assignment. Please keep the syllabus close by excuse me, as it gives you a tentative list of topics and when we'll be covering them. So just in case you want to look ahead to see what's coming, you can, and you can see what we'll be doing throughout the whole semester. Also, the syllabus shows when your midterm and final exams will be. So keep in mind the tentative list of topics can be modified if I need to, because some groups might need more coverage of functions, while other groups might need more coverage of, let's say, loops. So I have to build the course so it's structured enough, but yet allow some flexibility in how quickly or slowly we move through certain material. So just keep that in mind. Programming 1 is a first semester, typically freshman programming course, and each of you will focus on developing your foundational knowledge of computer programming mechanics. This will include defining variables and assigning values to those variables. We'll look at data types and what those are all about. We'll look at how to loop through code a number of times, or we call them looping constructs. We also have things called branching techniques, such as if. We have an if statement that we can use. We also look at input and output to the screen and to other files on your computer. And we also take a deep look at functions. So what we do is focus in on developing really good programming habits. From looking at program structure, top-down and bottom-up design techniques, code walkthroughs, and debugging skills. More often than not, out in industry, if you do work on computer code, you'll likely be doing a lot of debugging. So we'll be showing you some techniques to do that. These are the high-level learning objectives for the course. So by the end of the course, each of you should be able to demonstrate a beginning competency in computer programming with C++. Also, you should be able to identify and resolve basic computer programming bugs. Okay, those will be your debugging skills. You'll also demonstrate the ability to use an IDE, or integrated development environment, to write and debug your code. And you'll also be able to apply the software lifecycle methodology to programming projects. Now, these are very high-level objectives. I have more detailed objectives for each of the units that we'll be going over. There'll be objectives for making sure that you use Boolean operators properly. There'll be objectives that you use looping constructs properly, and so forth. This is a list of the materials that you'll need to work with during the course. The first is the textbook, which is Walter Savage, Problem Solving with C++, 8th edition. I cannot stress enough that the 8th edition is absolutely required. You may not use a previous edition. That's because the editions are just different enough to make your head spin when I tell you something's on page 37, number 3. Well, page number 37 in a previous edition might not even have a number 3 on it. So just keep that in mind. You will need the 8th edition. Also, for software, you have two options for an integrated development environment, which you will have to download and install and prove that you installed it by the end of the first week. Really, I need you to do that before Thursday of the first week. So the software that you can use, I highly recommend, is CodeBlocks, and it's available at SourceForge. Pick that up, and there's a direct link for it right on the screen here. You can also pick up a copy of Dev C++, which is available at Bloodshed Software. You'll need to make sure that you get the IDE that contains MinGW and GCC. That's critical because those are the actual compilers which you will be using through your IDE. There's some supplemental and supporting material that I will be providing to you. I provide all of the PowerPoint slides from the textbook to you, and I'll make those available in Noodle. There's also some supporting materials on pearsonhighered.com/savage, or from the CD if a CD was included. Also, there's several websites that I will point you to that have C++ tutorials and so forth, so those will be helpful. Also, from time to time, I'll be actually assigning YouTube videos for you to watch, and I'll expect you to watch those. That's pretty easy, I hope. And if you're a freshman and you need permission from your cadre to watch them, you can tell your cadre that it's for a homework assignment. Okay, and I have had to write letters for students before telling cadre basically to lay off and allow you to watch those videos. For non-freshman students, that isn't a problem. This screen shows the assessment criteria, how you'll be evaluated this semester. The biggest portion of the grade is programming assignments and your homework. So you'll be working on programming assignments almost daily, and you'll have mini assignments through My Programming Lab, and you'll have more complete programs that you'll have to submit as well. So all of these combined will be your homework grade, 50%. You'll also have weekly quizzes that are based on the content, my lectures and discussions, and the readings. That's 20%. You'll also have a midterm and final exam, each 10%. And then something I call API, attendance, participation, and interest. And this includes in-class teamwork and in-class programming assignments. That's also 10% of your grade. You can also see the criteria for grading at the bottom of the screen here. You need a 60 or better to pass, a 93 or better to get an A, and you can see the breakdown in between there. How I grade projects. Well, every single project that is submitted to me is graded on a 10-point scale, and I use a rubric, and that rubric can be found in the Noodle course room, and I present you pretty much a blank copy so you can see how I evaluate your programs. Late programming assignments are not accepted, okay, except via the use of coupons, and I'll talk to you probably the first or second day about what these coupons are and how you can use them. So you'll get one sheet, each student will get one sheet of coupons that you can use at any time during the semester, but you have to use it before you submit something. So you can't come to me after the fact with a coupon and say, oops, I forgot to give it to you. That it won't work that way. So it's kind of different. I hope you like it, but I'll make sure I explain the use of coupons in the class. That's my kind of fun thing. I always try and make things fun in the class. So that's something new that I'm trying this semester. Let's talk about quizzes for a sec. Quizzes are 20% of the total course grade. Each quiz is given at the beginning of each week to ensure that you're reading the assigned material prior to coming to class. So quizzes are short and directed to a specific learning material. For example, you might have a quiz on loops, which is based on your reading and in-class discussion and lectures. The quizzes will contain multiple choice, fill in, some writing of code, and then something that I call what's wrong with this code. So the quizzes are designed to take no more than 10 minutes. After 10 minutes, I collect every single quiz, whether you're finished or not. And those are designed to keep you accountable. Something that you need to know about the midterm and final: they're each worth 10% of your final course grade. The midterm covers all of the material presented in the first half of the course and will take place around the midpoint of the semester. Then the final exam is comprehensive, meaning it covers the entire course. It covers all of the material that you've learned during this semester, and that is also worth 10% of your final course grade. Here are your responsibilities as a student in this class. You need to listen with care during class for any assignment additions or changes, because when I set up this course, I basically provide a list of tentative assignments and tentative topics, but things change. Sometimes I may find that an assignment needs to be tweaked or changed, so you'll need to pay attention for those. And typically I'll announce those near the end of class. Also, when you submit an assignment to Noodle, you need to submit it to the proper location in Noodle. I've had more issues, and many issues, with students submitting their Noodle assignment to the wrong place. And unfortunately, I can't undo what you've submitted. So it makes things very challenging. So in order to get full credit, you'll need to deliver those assignments to the right place in Noodle on time and complete. Each assignment must be free from both syntax and logic errors. Right now you may not fully understand what syntax and logic errors are, but you will learn very quickly what those are when you compile and run your programs. The program that you submit must compile on my machine and be fully commented in order to receive credit. So again, you'll know very quickly what compiling means and what I mean by commenting your code. Now, if you haven't signed in to Noodle yet, I highly recommend you do so very soon. One of the things that I use Noodle for is for you to submit your files, and then I can review them and provide feedback to you on each of those assignments. And I generally try and get you feedback as quickly as I can, usually within a few days of you submitting the assignment. And the maximum time that you'll have to wait to get feedback is a week. This is one of those topics that I don't really love to talk about, but it's definitely necessary today. I take honesty, integrity very seriously. We have something called academic integrity. If you're not familiar with that, that's basically discussing plagiarism and cheating being very serious offenses in programming or any class in higher ed. And these can be punished if you end up cheating or stealing somebody else's work. It can be punished by failure on an exam, paper or project, failure in the course, and or expulsion from the university. In programming, you do not want to copy and paste any code from the internet and submit it as your own. That constitutes plagiarism. Doing so will result in a referral to the Academic Integrity Committee. So if the programming assignment gets challenging, we actually have two TAs or two peer tutors that can help you be successful with the computer programming. They're fantastic young ladies that really have excelled at computer programming, and they want to help you and want you to be successful, and so do I. When you complete your programming assignments, the use of the internet for any assistance is strictly prohibited. If any of your source code resembles code that's lifted from the internet, it will be considered plagiarism and cheating, and that case will be forwarded to the Academic Integrity Committee for their review. Once it's submitted to the Academic Integrity Committee, it's out of my hands, and they can make a decision whether there really was plagiarism or not. So keep that stuff in mind. This slide just discusses a couple more expectations. I really don't want you to use the internet during class and lab time because basically I consider that being disengaged from the course material. I've discovered students chatting using Facebook and so forth during class, so please don't do that. However, from time to time, if we're working together on an in-class assignment, I may say, okay, it's okay to use the internet to look something up. You know, if I ask you to look something up on the internet, of course that would be okay. And finally, if you do use the internet during class time, I may ask you to leave the class. Now, on a more positive note, by the end of this course, you'll know how to write programs using more than one file, what variables and data types are, how to write functions, how to control the flow of a program, how to iterate or loop through the same code over and over until some criteria is met. That's cool. And what the difference is between pass-by value versus pass-by reference. And one of the things that I do to help you learn how to write computer programs is by creating basic computer games. Maybe including a guess the random number, like I pick a number from 1 to 100 and you have X times to guess the number. Or we can write a program that allows a user to play Mad Libs. And if you're not familiar with Mad Libs, I'll demonstrate one. I'll show you one. And of course, you'll know how to compile and debug computer programs. Now, if you're looking at this slide and wondering what this adjustment time is, this slide is just for use in class, for an in-class activity with the recipe that I posted up on Noodle. This is the last slide, so thank you for watching this presentation, and if you have any questions, do not hesitate to contact me. Thanks. Have a great day, and I'll see you in the class.